In this video, I'm going to cover section 9.3, Measuring Volume from Contemporary Mathematics by OpenStax. The learning objectives of this section are to identify reasonable values for volume applications, convert between like units of measures of volume, convert between different unit values, and solve application problems using volume. So volume is a measure of space contained within or occupied by three-dimensional objects. So for example, when purchasing a SUV, a sports utility vehicle, you may want to compare how many cubic units of cargo the SUV can hold. So cubic units indicate that three measures in the same unit have been multiplied together. So for example, to find the volume of a rectangular prism, you would multiply the length units by the width units and the height units to determine the volume in square units. Or this should actually say cube units. That is a typo. Let's go ahead and we would say cubic or cube units. So 1 centimeter times 1 centimeter times 1 centimeter is 1 centimeter cubed. So the formula used to determine volume depends on the shape of the three-dimensional object, but again, like we did in the last section, we're going to limit our discussion to rectangular prisms so that everything just kind of works out nicely for now. So the volume of a rectangular prism, which you can see here is just like a box, is length times width times height, or V equals L times W times H. So it's a good formula to have. So we had this table in the last unit, so let's just kind of review what it's talking about. So again, if we multiply 3 kilometers together, length, width, and height, we get a kilometer cubed. But remember, 1 kilometer is 1,000 meters. So when we're cubing things for volume, that's going to be 1,000 meters times 1,000 meters times 1,000 meters. And so what you're looking at here is 1,000 million, a billion. So you're looking at 1 billion cubic meters are in a cubic kilometer. Or like, for example, going from meters cubed to decimeters cubed. This is decimeters. So a meter has 10 decimeters, so that's 10, 10, 10, so that's 1,000 decimeters. And kind of the same, well, from decimeters to centimeters, I don't feel like that should be a million. I think somebody else made another typo from the textbook. Should just be 1,000 again. And then centimeters to millimeters would be 1,000. You just keep going one step down. Meters, decimeters, decimeters, centimeters, centimeters, millimeters. Each of these should just be 1,000. So again, textbook, company, free. So 1,000 centimeters cubed. All right. But they got it right over here. So, So let's look at this example. A grandparent wants to send cookies to their grandchild away at college, which represents a reasonable value for the volume of a box to ship the cookies. Would it be kilometers cubed, meters cubed, or centimeters cubed? Now remember, 1 kilometer is on the same scale as a mile, so 1 mile is 1.6 kilometers. So that's way too much. You're not sending this grandparent isn't sending their grandchild like cubic miles worth of cookies. I don't even know if that's like what that would look like. That's crazy. And then a meter is on the same kind of playing field as a foot. But we're talking about 3,000 of them, so I don't think 3,000 square or cubic meters is going to make sense, because what we're really talking about is like a box, right? So we've got this shipping box, like a flat rate box. And so we've got length, width, and height. So if you're talking about feet, right, then this is getting on the scale of a house. Right? You're talking about like 3,000 cubic, like if this was in feet, because again we can think of meters on the same level as feet, like 3,000 cubic feet, then you're talking about like the size of a room. As we're centimeters, that's on the same scale as inches, so that's going to make more sense. So we would want to say, well, that's going to be 3,375 cubic centimeters of a box. And then over here, we kind of have that, so volume in kilometers, that which is far too large. And then for meters, again, way too large. So centimeters is kind of our Goldilocks amount here. So what about converting between these different volumes? So you can see, like we showed on that table, that this time it's a factor of 1,000 for that volume. And the reason for that is visually, let me change colors of this pointer. I like purple. So again, if we drew that rectangular prism, which is, just a box in 3 dimensions, right? And let's say, let me even do a better job. Let's just try to pretend that this is a cube. All right, so we really want it to be a cube. So let's do. So kind of this nice little cube where everything's the same. And so, for example, let's go from, let's say this was 1 meter, right? And this was 1 meter, and it's 1 meter tall. Well, that's equal to 10 centimeters, 10 centimeters, and 10 centimeters. So volume is length times width times height. So you're talking about 10 centimeters by 10 centimeters by 10 centimeters. So that's 1,000 centimeters cubed is 1 meter cubed. And so that's what we're doing here is when we're going from, for example, oh wait, that should have been decimeters, sorry. So decimeters. So going from a cubic meter to a cubic decimeter, we would multiply by 1,000. And that's where we kind of get that factor of 1,000. And so when we have, like, for example, any jump between these two going right would be a multiplication by 1,000, and any jump going left would be a division by 1,000 as far as volume is concerned. All right, so volume we're going to measure in cubic meters in this case. So let's look at a basic example. A pencil case has a volume of 1,700 cubic centimeters. What is the volume in cubic millimeters? So we're going to a smaller unit, so our number is going to get larger. So we've got 1,700 cubic centimeters. So I'm going to do this kind of visually first. So let's say we have this pencil case. Pencil cases are kind of rectangular, right? And so the volume is 1,700 cubic centimeters, right? And so we've got this pencil case, and we want it to go to, we want that value to go to cubic millimeters. So centimeters are a larger unit of measure than millimeters. So that means our number is going to get larger. because there's going to be more millimeters in a centimeter. So the way we would do this in the table is that we want to get rid of centimeters cubed. We want to end in millimeters cubed, right? And so 1 centimeter cubed is going to have 1,000 millimeters cubed. Well, why is that? Well, go back to your little perfect square, or perfect cube, rather. Okay, and this is 1 centimeter. This is, again, 1 centimeter. And it's a centimeter wide. And so, remembering our prefixes, 1 centimeter is 10 meter, or 10 millimeters. So 10 millimeters, 10 millimeters. So 1 cubic centimeter, multiplying length times width times height, is going to be 10 times 10 times 10. That's going to be 1,000 cubic millimeters in this case. So 1 cubic centimeter is 1,000 cubic millimeters. That's what this says. So we're multiplying. And so that's going to give us, in return, 1,700,000. So 1,700,000 cubic millimeters, or 1.7 million cubic millimeters, is what we're going to have for the volume. So see how we went from a smaller number to a larger number? That's because we went from a larger unit to smaller. So if we go from larger unit to smaller unit, that means our number is going to get bigger. It's kind of like going from well, there's nothing, we don't, in the US, in the system, we don't have something like smaller than an inch that I'm aware of. There probably is, that it's just not standard. It's like going from feet to inches, right? You're going to have more inches in a foot, so that means you're going to have more. Whereas more, there's more centimeters in a, or sorry, there's millimeters in a centimeter, so that number gets larger. So what about this example? A shipping container has a volume of 33.2 cubic meters. What is the volume in cubic centimeters? So again, thinking about this, we've got, so we're going from the base unit meters over 2 to centimeters. So we're really looking at a conversion factor of 1,000,000. But let me show you how I know that. So again, let's draw our perfect cube. That is not perfect, but you get the gist. So this is a meter, this is a meter, and then it's a meter tall. And there are 100 centimeters in a meter. So that's going to be 100 centimeters. And so 1 cubic meter is going to be 100 centimeters cubed. I'm going to shorthand it like this by cubing it. So 100 cube is 100 times 100 times 100. So that's 6 zeros with centimeter cubed, which is 1,000,000. So 1 cubic meter has 1,000,000 cubic centimeters. So if we're going from 33.2 cubic meters, and we are wanting to end in cubic centimeters, then cubic meters needs to be on the bottom, and 1 cubic meter is 1,000,000 cubic centimeters. And so that is going to equal, when we multiply, 3, 3, 2, 1, 2, 3, 4, 5, I believe. So let's do this. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So that should be our cubic centimeter amount. So we went from meters, which was a larger unit, to centimeters, which is kind of 2 powers of 10, so 10 squared smaller. So it's 100 times. Centimeters is 100 times smaller than a meter, so that's why we get such a large amount. So, yeah. All right. Well, let's see. A holding tank at a local aquarium has a volume of, that is, so 3, 6, 9, 22,712,000,000 cubic centimeters. So what's the volume in cubic meters, which makes a lot more sense to have given it in. So again, we just talked about that that relationship that one, not centimeter, it is 1 cubic meter is 1,000,000 cubic centimeters. And so we are going from 22,712,000,000 cubic centimeters, and we want to end in cubic meters and get rid of, we want to end in cubic meters, get rid of cubic centimeters, and 1 cubic meter has 1,000,000 cubic centimeters. So cubic centimeters cancel, and we are doing the division. Now again, dividing moves the decimal to the left, so 1, 2, 3, 4, 5, 6. So what we're looking at here in terms of cubic meters, right? In terms of cubic meters is 22,712 cubic meters. So it's a quite a large aquarium, actually. And we're talking about like a local aquarium, like holds a lot of fish. All right. So another interesting thing about volume is, we've been measuring volume in cubic amounts, right? So we talked about like a cubic meter, but we also have this equivalency. So 3 lines that looks like an equal. This is equivalence. That has an equivalence to volume in terms of like liters. So this kind of happens in the US system, in our normal standard system. It's not as pretty as it is in the metric system, because in the metric system everything's just base 10. Everything's just divisible by 10 and moves around in that kind of regard. But in the metric system, we have this nice relationship between centimeters or cubic centimeters and liters. So one example is, that's kind of the hallmark that I've highlighted here, is 1,000 cubic centimeters is a liter, or 1 cubic centimeter is a milliliter. So these are used a lot in the medical field. So if you ever hear the term cc's, so they say we need 5 cc's of something. Cc's means cubic centimeter. So 1,000 cc's is what they would say, is equal to 1 liter. or 1 cubic centimeter, 1 cc, is 1 ml, or 1 milliliter. So you'll hear mLs or cc's in the medical field when we're talking about administering drugs and those types of things, medicine. But that is because that is measured in metric units. And they have this really nice relationship between this cubic volume and this liter volume. So let's look at that. A holding tank at the local aquarium we just looked at had 22,712,000,000 cubic centimeters. What is that in liters? All right, so from our previous example, we would need to kind of do this twice if we hadn't done this already. But we have already seen that 22,712 cubic centimeters. All right, and we want to convert this to liters. All right. So we want to get rid of the cubic centimeters. So 1 liter is 1,000 cubic centimeters. And so in so doing, that allows us to cancel cubic centimeters and basically get rid of 3 zeros, but we can do 1, 2, 3. We can do that decimal movement because dividing by 1,000 moves the decimal place 3 to the left, so that's going to be 22712. So that's 22,712,000 liters of capacity at this aquarium. Again, that is quite a bit. Just to give you an idea, 1 liter, we haven't really talked this, but 1 liter is about 0.26 gallons. So, just to give you an idea, like a liter is about 1/4 of a gallon. All right, so a liter is about a quart. Right, so a liter and a quart. So 1 liter is about 1 quart in the U.S. system. So you're talking about 22 million quarts of water. So if you multiplied that by 4, then you're looking at about how many gallons of water that aquarium has. So it's kind of interesting, but just to give you an idea of, in your head what that looks like. So what about an airplane? It uses 150 cubic meters of fuel to fly from New York to Hawaii. How many liters of fuel did the airplane use? So again, this is kind of a multi-step problem because, if we knew off the top of our heads what, how many, the conversion between cubic meters is, I just kind of want to show you how I would reason through this because I don't have off the top of my head the conversion of cubic meters to liters. But I do know that if we start with 150 cubic meters, I can take that to cubic centimeters, right? And so a cubic meter is 1,000,000 cubic centimeters. Here's how I logicked that. So remember, every jump is 1,000 times in cubic in volume. So we're going from meters to centimeters. So that's 1,000 and then another 1,000. So that's 3 zeros and then another 3 zeros. So that would be 1,000,000. And so that's going to get rid of that. And then we want to go from cubic centimeters to liters. So we can actually extend this out one more time and do this one more time to get liters. And then we know that 1 liter is 1,000 cubic centimeters, right? And so if I multiply it straight across on the top, I'll go ahead and do that. So centimeters cancels here. So we're going to have 150 times a million. So that's 150 million. And then on the bottom we'll have 1,000. And then we're left with liters. So what that gives us is, again, that's just canceling 3 zeros. So we're talking about 150,000 liters of fuel that was used to go from New York to Hawaii. And again, if you multiply that by 4, that's how many gallons you're talking about. So, kind of interesting there. But that would be, excuse me, what we are looking at in terms of the fuel cost to go from New York to Hawaii. All right, let's look at one more example. A carton of juice measures 6 centimeters long by 6 centimeters wide and 6 centimeters tall. So again, I'm a visual person. I'm just going to go ahead and go over here and I'm going to draw that. So we got this carton. This is our juice. And so its base is kind of square. So we got 6 centimeters by 6 centimeters, and then it's 20 centimeters tall. And a factory produces 28,800 liters of orange juice each day. So how many cartons of orange juice would we produce each day? So first we need to figure out, well, how many liters does each of these little cartons hold? So the volume of the carton is going to be 20 centimeters by 6 centimeters by 6 centimeters. So I'm going to get a little calculator and just kind of do that real quick. And that's going to give me 720 cubic centimeters. All right. Now, we need to figure out like cubic liters, or sorry, not cubic liters, liters. We don't want cubic liters. So we've got 720 cubic centimeters. And remember, we want to go to liters. All right. So 1 liter is 1,000 cubic centimeters. So this is going to give me 0.720 liters, because again, dividing by 1,000 is just moving the decimal place 3 to the left. So that's going to be 0.720 liters. All right, so each carton can hold 0.720 liters, and we are wanting to fill each of these little cartons with the juice. So we would say, all right, we got 28,800 liters divided by 0.72. I forgot my 2. I'm sorry. So let's go in and fix that. So 720. And this actually has a compound unit. This is liters per carton, right? So this is how many liters per carton. So what ends up happening is we end up getting these liters to cancel. And so if we do 282, or sorry, I dropped an 8 here. There we go. So 28,800 divided by 0.720, that gives me 40,000, and that is in cartons. So we're talking about producing 40,000 cartons of juice each day. with that type of calculation. And so that's kind of interesting there. Alright, so that's the end of this video for section 9.3. If you haven't already read the unit, go read the unit and try those your turn problems that are there in section 9.3. The answers to those are in the end of the section so that you can check your work to make sure that you're understanding what has been talked about in the book and in this video. And then once you're done with that, head on over and complete the homework assignments in the LMS.